Okay, so today we're going to be working with decimal numbers. Okay, so the first question with this decimal has us doing two things. So the word estimate, okay, means don't give me the exact answer, just kind of think about what it might be-ish. So let's put some stuff on the number line here. All right, so here's what I would do. I could say 2.65 I'd be about right there, right? Then this says to go down, right? Subtract to go down. I'm not going to go down quite 4. So just shy of 4. So 1, 2, 3. This would be 4 down. So I'm not quite 4 down. So what do you want to estimate? Maybe -1? Okay, that's an estimate. Okay, so we're going to calculate what it really is. So what was my rule about adding with positives and negatives? If they are different signs, we should add or subtract their values together. Different signs, we're going to subtract. Okay, so I'm not going to worry about the order. I'm just going to take what's the biggest, subtract the smallest. So 3.81 subtract 2.65. Okay, and I'm lining up my decimals. Remember that? The decimals get lined up. Okay. 1 subtract 5, can't do. Borrow. So change that to a 7 and 11. 11 subtract 5 is 6, 1, 1. Now going back to the question, what do you have more of? More positives or more negatives?
More negatives.
You have more negatives? Ooh, look at our estimate. We guessed that our answer should be -1. Okay, next question. What do you do when you subtract? So change it to addition and then change the sign of that. Okay, or sometimes people think of subtracting negatives, just make pluses. Okay, that's another way to kind of think about that one as well. Okay, so subtracting, I always change to add and then change that one. Okay, so let's make a little bit of a number line here because we have to estimate. So I'm going to go 0, I'm going to go to -6. 1, 2, 3, 4, 5, 6. So here is my starter spot, really close to -6. And then I'm going to go up, and I'm going to go up almost 7. So 1, 2, 3, 4, 5, 6, 7. And I'm not going to go up 7. I'm not going to go up 7, just a little bit under that. So I'm going to estimate that it's about at a 1. Okay. So what do we do here? Should we add their values together or should we subtract their values? Subtract. They are different, so we're going to subtract them. So I'm just going to write the bigger one, subtract the smaller one. Okay, we have to do some borrowing right away here. So 13 instead of 3. So 13 minus 6, 7. Uh-oh, we have to borrow again. We can't do 7 minus 9. So 17 minus 9 is 8. And what do we have here? Do we have more negatives or more positives? Which one is the more? Positives. And look at our estimate. We estimated at 1 and we got to 0.87. Okay, there's 2 questions here that say show you know. So you're going to do those on your own and I'll put them on the board and then we'll compare. So checking out how you did. A couple things I did was I first noticed that these were different. This was a negative and positive. So I subtracted their numbers. Okay, and then decided that I'm negative because there's more negatives than there were positives. This one was different because I was having a negative value plus another negative value. So they were the same sign. So what I actually did was add their values together. And then decided that if I'm doing negatives and more negatives, my final answer is negative. Okay? That's good? All right, so let's go to the next page where we're going to do some timesing and dividing. Okay, so if you remembered when we were working with decimals, we talked about how many decimal places we were going to have as an end. So this one has 2 decimal places, and this number has 1 number after the decimals. So my final will have 3 decimals in it. Okay, so here we go. 45 times 1, or 12, we'll go like that. So in my timesing, I'm doing nothing with decimals. I avoid the decimals now. Okay, so here we go. First item, it's 2 times 5, so 10 carried. Next is 2 times 4 plus the extra 1. 9. Okay. Now we need to skip a placeholder because we're going to go to this 1, which is over a place. Okay, so 1 times 5 is 5, and 1 times 4 is 4. Okay, so now we go back and we said we have to have 3 decimal places. So 0.540, there's my 3. And what is my final answer, positive or negative? Negative, because there's a positive times a negative makes negative. Okay. The next one, I think we haven't really done a division yet. Did you have any in your booklet last time? I don't think so, right? Okay, so we're going to go, forget the negatives. What is our final answer if you do a negative divided by negative? Positive. Okay, so our final answer is positive. So we're not going to write the negatives in. We already know what our final is going to be. Bless you. Okay, so this is what the question would look like, but I'm not going to do that. I'm going to work not decimals. How many places would I have to move the decimal so that I don't have any?
One? Or on which one?
On all.
Three, yeah.
To get rid of the decimals, I would have to move 2. Okay, because this is 1, but if I only move 1, that doesn't do it there. So I have to move 2. Okay, so if I move 2, what does my new question look like? 25 divided by 230. Okay, here's my question. How many times can you put 25 into 2? How many times would it fit? None. How many times can you put 25 into 23? How many times? 0. Okay, so now we're up to how many times will we put 25 into 230 without your calculator? 9. How'd you get that so fast?
Yeah, 9 times 200 is
200? Yeah. So 20, this should be some mental math. 25 times 4, you should know that with money, right? 4 quarters is $1. So then 25 times 8 is 200. And then you can fit one more. Okay, so 9. So what are we up to if we have 9 times 25?
925, or 225.
225.
925.
So that leaves me with 5 left over. I don't have anything to bring down. So what could I do? I could add a decimal of 0. Because you're not changing the number by adding decimal 0, right? You're not changing the value of anything. So if I bring that down,
50.
how many times can you fit 25 into 50?
2.
2. But what do you need? Because you added this decimal, you need to add a decimal there. Okay, lining up that decimal that you threw in there. Okay, and we decided our answer was going to be positive. So then we just leave it like that. Okay. Are you okay to try on your own here? So you need to kind of do 2 things. You need to remove decimals and then put decimals back in. And you need to understand 2 negatives make what? Negative and positive make what? Okay, those are some things to think about. Okay, so the first example, I got rid of the decimals. So I like to do the bigger numbers, so 61 times 6. Okay, and then I decided because there was one decimal, my final answer needed to have 2 decimals, and negative made me positive. So that was good. Check that you got it right.
Check.
And here I set it up as it was. I avoided any negative signs till the end. So this is what it looked like. And to make sure there was no decimals, I would have had to move 1. So I moved the decimal to 20 and 24. I got that I could fit 20 into 24 once. And then because I had nothing else to carry down, I added a decimal with zeros, which made a decimal up there. Okay, and at the very end I checked negative divided by positive should make me a negative answer.
Yes. What verse did you get on?
Okay, so here's a word problem. So we have the temperature at Blood Reserve in Alberta decreased 1.2 degrees Celsius per hour for 3.5 hours, and then it decreased this much for 1.5 hours. So how much did it decrease altogether? Okay, so tell me what kind of math I should do here. If you're doing 1.2 every hour, over 3.5 hours, should I add these, subtract them, multiply, or divide them? You should, yeah, multiply them. If you do this every hour for 3.5 hours, so we're going to multiply that. So 35 times 12. 35 times 12. Okay, so get the 2 times through. So that should give you 70. And then the 1 times should get you a 5 and a 3. And how many decimal places should I put on this 420? 2. So 1, 2. So 4.20. And we're just going to put a negative on there because that's how much we went down. Okay. Then it did some more decreasing. Now, so here we go again. So are we going to do the same thing? We're going to times. So I'm going to do 15 times 9. So again, no decimals on it. 15 times 9. So 135. And how many decimals should I go into that? 2. Because this has 1 and this has 1. And I'm going to put negative. So here's my question A. What was the total decrease in temperature? So it went down this much and then this much more. So what should I do mathematically with those numbers? Add them. So you went this much down and this much more down. So how much down is that all together? Okay, so they're both negatives. So you should add their numbers together.
555.
Yeah.
555, ooh.
Let me cook. I said it before you did.
Okay, so there's my answer for A. It went down that much all. Okay, and then the last question says, what's the average rate? So it's going to be the whole thing divided by the whole hours. So we're doing the whole decrease divided by the whole span of time. Who can mathematically, mental math, how much time has passed altogether? 5 hours, because you are 3.5 plus 1.5, 5 hours. Okay, I'm actually going to do this with the decimal in it. I'm going to show you that. So I should have said this before. I don't want decimals on this. I think it's okay if you have decimals here. Okay, how many times does 5 fit into 5? Once. 0. How many times does 5 fit into 5? Once. And once, right? And where's this decimal? Keep it lined up. You're going to keep that decimal lined up. So we're going to answer like this. It's going to go down 1.11 degrees Celsius per per 1 hour for each hour?
That was cool.
Okay, you okay if I maybe skip one question? I think this next question was very similar. This one was very similar. So maybe we'll do it as a recap for tomorrow. Okay, so let's try the last one then. Okay, student did experiment. The temperature went from this to this in 10 minutes. So how much did the temperature change per minute? Okay, so first and foremost, we have to figure out how much did the temperature change. So what do you want to do with those numbers? You got your add, subtract, multiply, divide. You're going to subtract them, yep. So the total change is the difference. So give me that value, the difference. So you're going to have to borrow from 50, which would make that a 49, right? Okay, so that's how much it changed in 10 minutes. So we've changed that much in 10 minutes. So I want to know the unit rate, which means how much change per 1 minute. So how do I change 10 into 1 minute?
Divided by 10.
We're going to be doing dividing by 10. Okay, and I'm good to divide because I don't have any decimals with this 10. Okay, so how many times can you fit 10 into 2?
0.
No. So 10 into 29.
2.
2, so 20.
Bless you. Bless you. God bless
Okay, so the new question is how many times can you go 10 into 96? 9. So that is 90, leaving me with 6. And then there's nothing to pull down, so what could I put here? Zeros. So that is exactly 6, and we're done. What about the decimal? Where would it go? After the 2, because it needs to line up with that decimal. So our temperature was changing 2.96 degrees Celsius every minute. And should I put a plus or a minus on that?
Negative. Right? Because it's dropping.
Well, let's check this out. It went from here to there. So would you say the temperature is doing a plus or a minus?
I was still thinking the others. I was still thinking
Of the decreasing question. Okay, so this shows me that the temperature is increasing.